Good afternoon, everyone. Time crunch. I have to start with a time crunch. Okay. So I'm Ranjini, and introduction is already done. So now that we heard all powerful ladies spoke about the signals to sense and all that stuff, so my topic is around the signals, kind of a signals. So how this cybersecurity can be implemented in critical infrastructures. Like there are many, they are marine, they are in railways, they are in big industries, all that the critical infrastructure, how this cybersecurity plays a very important role to be implemented, and my topic in that is about operational technology. Okay, so how this industrial automation control system can be, life cycle takes to implement cybersecurity and its compliance and standards. What is the cybersecurity standards that we follow here? It's 62443, and what are the key components of 62443? How that standard helps for across the critical infrastructure, different domains, as I said, like marine industries, railways, and whatnot, all the critical industries that we follow, how it can be implemented, and what is that architecture, and what is that IT and OT convergence that happens between that, because it was all legacy prior, and now slowly the IT systems are getting implemented, the compliance are getting implemented, and the lot of security things are coming in. So there is somewhere the cloud and the security and the cyber all coming together. That's the IT and OT convergence that I say in the slides. We'll see further. And what are the key components of ISCS and the convergence of all these three, as I said. Okay. So coming to the point where what is this? It is already comprises of lot of hardwares, lot of field devices, lot of softwares, and a lot of policies that has been implemented to secure, safe, and make that whole operation reliable, securized, more secure, because in IT it is just a security and systems go down. That's what we hear. But here, if single device goes down, the whole architecture or a system or big devices, if you see a lot of water filter, what we have, plants, water plants, big water plants, all that goes off. So the values that we give, the connection between the devices, everything that goes into the secure life cycle, and the lot of security is required more than the IT systems. Going to the next, and what is that life cycle? How that standard helps, as we see here. So there are different bifurcation that happens. So basically, from the design, engineering, cybersecurity, if you see for the top level, 1, 2, 3, where 62443 standard from ISCIC standard, it has 13 substandards where it will divide each level of secure SDLC and secure STLC. It's nothing but secure SDLC and secure STLC that we have to implement across these complete life cycle between the IT, OT, and convergence. So how that standard will give, bifurcate, it will break into chunks and then give us, help us, what needs to be implemented, what stage, what we need to do at the design phase, and all the levels are here. I think it is pretty much explainable. So risk assessment, 3-2, IS assets, security, identify your assets first, classify your data, do your design reviews, do your architecture reviews. There goes on the development and implementation. And what are your cybersecurity requirements, which is derived in 3-2 again, and design and engineering cybersecurity countermeasures, what we have to implement. So all these LO1s will go in hand, all this 1 to 3 will go hand in hand. And at last, cybersecurity maintenance and monitoring in 2-1, 2-2, it's the maintaining phase, it's the development and implement phase, and assessing phase. So how these standards will give big chunks, break into different substandards, and then which will help development team, IT team, and the maintenance team to help on where this whole, if it is implemented, the product or application hosted on cloud can be certified from the ISCIC board. Again, this is a more explanation, or the latest which I have captured here. The latest is what you look here, the evaluation of 6-1 and 6-2, and 5x is yet to be given. But however, till now, all that we had is one general policies and procedures, system, component, and product. But the next further that we have is profiles and evaluation, which is yet to come, and they are deriving. And most of the companies that we go here is 4-1 and 4-2, which I'm working on. And this is all ISA 99 to be approved, all these. So it is just still happening. Again, I have extended more on these standards because it will help which phase what it will fall in more detailed manner. Okay, now how does that architecture really looks like, right? So there are different, where are our devices, where is IT systems, where is our lines, where is our SCADA, where is our PLCs, where is that corporate thing sitting, right? Where is our cloud and ERP? So if we go from bottom, the devices sits in the really bottom, and it gives the data, the process is done, the line awares, the sensors are there, field devices are there, sensing devices are there, which sends the values to the upper level, the SCADA, the PLC, program controller is what we say, and the SCADA is the system. How these different systems communicate between and remotely I/O control, and how does it process the value and then move on to the next devices network architecture, how does it is reporting dashboards, how is that we are visualizing. Power BI is what we use in my current, but that's where the line that passes here, and all the data that is coming, flowing, converting, different data are sitting, whatever it is flowing to till cloud and ERP, how is that going and setting? So it's all gathering there. So how this cloud is getting slowly involved into OT or critical infrastructure, which we didn't had back then. Right now, this is the structure that it follows when we are automating our devices data to the cloud, where we can monitor the things. That's where the AWS security, God duty, and the AWS 360 view degree, all the security services, if you implement on cloud, it is all 360-degree view where we can watch all our systems in the one go. So these are the different components of ISCS. They are supervisory SCADA systems, they are controllers, they are HMIs, machine interfaces, where in the different levels, all these are different devices, which I showed in the previous. And this sits, all these things will sit there. It does its job and sends to the cloud all the data. So there are workstations, field devices, control devices, as I said. There are redundant systems, management systems, all these are the key components where it is useful. Okay. So these are the different things. And how this IT and OT convergence is happening. How our devices are sitting. How is that communication between different firewalls, between different networks that is happening, right? There are different sites. There are different big industry. There's a site 1, site 2, and I'm sorry, the trusted network and our mail servers. If any notification has to be sent, I'm sorry, I need water. Sorry. Okay, so this is how the systems are sitting. It will communicate between different smart devices, between different sites, and the data is going to a cloud between different workstations, the different enterprises, and the convergence between the IT and OT is happening. That's where the security for each site, each system, each device is so much important. So how is that? Why we call OT, IoT, and IT, different jargons, all the confusions. So this is why we call Internet of Things, tablets, tablets, smartphones, and how is that IT systems, what are this that we have in the IT system, we all know already. And what is that operational technology devices that we have? PLC, SCADA, HMI, all that I said I have all. And all the alarm, management systems and all that. And industrial, yes, sensors, temperature gathering, all these are different data that are coming through MQTT data or through telemetry. Train is somewhere, how the data is getting captured, how that data is signaling is sending, where there is no network, how is that holding data, buffering data, and then sends to the data when it is in the network area. Because if you see in Google or search, some hacking has already done. The train is stopped through firewall, through network, and there is a ransom. So these kind of different incidents have already happened. That's where this monitoring, IT/OT convergence and security is playing important area. With that, all that, this is my, I think, last slide. I'm a little super fast. You can ask me any questions later also. This is the 40-minute session, but I'm being super fast. Okay, so explaining, I have taken one example, marine. Ship is somewhere in the mid of the sea, mid of the ocean, and this is how the communication to a private cloud, to smart devices, to different warehouses in between, and offices, cargo, tracking, monitoring. There are a lot of CCTV, all the devices that I have explained, mentioned here. There are different electricity, gas, water, smart meter. These are different examples though, but the screenshot says completely how the data is coming from the ship to our systems or different teams that we are sitting here in the IT, right? And to track if there's all the securities are still good and going well in the mid of the C2. Any questions? Or you can ask me how to transition to this area. I can explain of the mic also later. But this is one example, but there are, as I said, railways and water plants, industries, marines, very big industries. And this cybersecurity is now emerging in these areas. Till now we have heard SOC, till now we have heard pen testing on their governance, compliance, DDPA Act, all that, NIST, CIS, everything. But pitching into this area is still niche. So, yep. That's all from my side. Thank you. Thank you for listening very shortly. You can ask me anything. Connect me on LinkedIn, Ranjini Kumaraswamy Joshi. Thank you.